So today, I welcome you to a continuation of project networking, which is one of the topics that we should cover thoroughly as far as project management tools and techniques as a unit is concerned. So we talked about what are some of the guidelines we need to follow when we are networking. And if I take you back a little bit to some of the things that I talked about in my last presentation, I've made a summary here for you. I'll share with you after this, that we should have only one entry. Remember, one node to mark the beginning of the project and one node to mark the end of the project. That is in our network diagram. Every time we are drawing our network diagram, the arrows that you're going to involve should be pointing forward and never come back, because if so, we'll be introducing what we call loops, and that will not be a good presentation of our project, because it means if you have completed an activity, then it's like you're coming back to the same activity, which doesn't show the outcome at the end of the day. Then we should not have hanging activities or what we call daggering activities or even events in the project. That everything should actually be having that particular interrelation to define the overall project. And more so, we would want to talk about a case where maybe we have a dummy. Don't choose a dummy anyhowly. There should be a reason. And more importantly, it's where you note there are more than maybe one activity, that you'll have them starting at the same point and you'd want to avoid them ending at the same point. So those are the major rules guiding the construction of a network diagram. But more importantly, once you're done with your network, you should be able to define what we call the critical path for the project, as well as the project's completion time, or rather the time that is going to be taken in that particular project. So with me presenting an example here of a project whose activity relation or interrelations have been provided in this particular table. And my project here constitute a number of activities, say from A to H, and they should be logically organized. I cannot have an activity A, then I'm learning all the way to activity F. No, they should be having a chronological and logical form of organization of the activities. And then there are some precedent relation that have been provided depending on where the activity is. Like for activity A and B, those ones are marking the beginning of the project, so they may not have their predecessors defined. But for any other activity that will come after, then they have to be relying upon the completion of the other activities. And so as we define our project, we'll be having our network based on what happened, that is our predecessor now, and where we are going to, or what is likely to happen after we think of a successor activity. In my document here, I've shared with you what we mean by a predecessor activity. It is an activity that must be completed, before the start of another activity. Like you cannot roof a house when you don't even have the warnings. So we have to have completed an activity like A for maybe another activity, let's say D, to begin. So activity A will be called a predecessor of activity, say D. Then where we are going to, what is going to happen after, immediately after the completion of an activity, whichever the activity that now commences, we call it a successor activity. It is an activity that begins immediately after the completion of another activity. So in our networking, we are going to think of those two things: the predecessor, where we are coming from; successor, what is going to happen immediately after; the completion of a particular activity. So we are going to draw our network diagram, and that's the first thing in any question. Other things will rely upon your network diagram. If well constructed, then you have a good case to rely upon as you answer other maybe questions. So let's start by drawing our network diagram. I'll be using nodes, the circles, to represent an event. And an event class is a point, an event is a point in network, which actually shows a point in the network, which shows either the beginning or the end of an activity. I repeat, an event which will represent using a node is a point in the network which normally marks either the beginning or the end of an activity. And I'll be using what we call arrows. So my arrows will be representing what? I'm drawing my network diagram based on what we call activities on arrows. The activities will be on arrows. So every arrow that you're going to represent on our network diagram, it would actually have a meaning of a particular activity. Then in our next session, we are going to draw a diagram, still a network diagram, where we are going to have the activities on node. But whichever the format we use, we should be having the same conclusion that our project time is like this, and also the critical path is this one. So let's start by drawing the entry. And we said this should be only one node. We have one node or one circle marking the beginning of the project. We call it our entry. And I'm going to be dividing my nodes into 3 portions, where on the first part of my circle here, I'll come and label what we call the event number. And on my 2 portions here, I'm going to come and label the earliest event time, the earliest to which that event can begin, and it also marks the earliest start time of an activity that will actually be coming after this particular circle. And on the lower end, we'll be representing what we call the latest event time, or the latest to which that particular event can actually commence in our project. Also, it could be representing the latest start time of an activity that you're going to represent here. For every time you're drawing your network diagram, keep on going back as many times as possible to what we call the project itself. Try and analyze what is happening in your project as much as possible to end up having a correct network diagram drawn. So activity A and B are marking the beginning of the project. Whenever you see this dash, yeah, there's nothing represented here, it means the beginning of a project. So activities A and B are to mark the beginning of a project. We can have an activity there. We'll call it A. And then here we have an activity. We can call it B. Don't rush into drawing the circles at the end of those activities. Go back to your work and find out what is happening. Once we have completed activity A, yeah, its successor is activity C, or rather, C has the predecessor being activity A. And what is happening towards the end of our project, we also find activity C and D have to come together at some point to act as the predecessors of activity G. And B is actually, you can see here, B is a predecessor of activity D. That D succeeds the activity B. So we can actually have those two coming together in that they didn't start together. Which activities am I talking of? Activity C and D. So C was to be the successor of activity A. As you can see from our work here, we can represent activity C there. Then activity D, its predecessor is activity B. I'm representing activities on the arrows. And remember, our arrows should always be pointing forward and never backwards. So there we can merge these two to become the predecessors of another activity, which you later on see from our project. Okay, then we have activity B again becoming the predecessor of activity E, and E has got no successor. We can push this one to the end of the project, call it activity E here. Then we also have activity F, which has the predecessor being activity B. This is activity F. And the moment we complete activity F, look at this. We have the activity H succeeding activity F, and H has got no successor. Any activity that has got no successor, you should be pushing it to the end of the project. So again, this one I'm going to push it to the end of the project. This is activity H. Then activity C and D were to give rise to activity G. G has got no successor. Again, we push this one to the end of our project. Good. All these, the three activities, did not have successors, meaning we mark the end of our project at this particular point. Let's make this one bigger. Since it's already at the end, we don't even require more space. So that is our network for the project. And we can mark the exit by having that particular node. I will come now and I label my nodes. I can call, and you have also to follow a chronological manner. It should be logical as you label this, in that an event number one will occur before the last event for sure. Yeah, then we can call this one maybe node number 2, event number 3 here, number 4, maybe this one we call it number 5, and lastly we have the last number taken by our last event, showing the completion of our project. I'm going to indicate the durations of these particular activities. For example, activity A has 5 weeks. My time is in weeks. Activity B has 4. Activity C has 2. Activity D we have what? 1 week. Activity E we have 5 weeks. Activity F we have 5 weeks again. Activity G we have 4. And activity H we have 3 weeks. So those are the periods defining, or rather the duration, defining each of our activity and given in form of weeks. Now, our project is not having a complete network diagram. Reason, we need to come and fill in the areas to which, for example, an activity, let's say A here, can actually begin. Also, let's say when can it earliest end, and the beginning of it is marked by a node, the end of it again is marked by a node. So these ones, we call them the earliest event times. So in the calculations of these particular variables, which are going to fill in on our upper and the lower ends of our nodes, we are going to use what we call the forward pass and the backward pass. The forward pass, usually we get what we call the highest or the largest cumulative variable leading to an event, And when we are working backwards, then we work using what we call the backward pass, and we'll be getting what we call the smallest cumulative variable, and we'll be moving from the last event here as we walk towards the first event. So in case we want to find our earliest event time, I've said we'll be using the forward pass, and we'll be working on the largest variable. So if there is any point of comparison, a point of comparison will be noted by some 2 or 3 nodes pointing towards a certain kind of a circle. And in such a case, we need to do what we call a comparison. We pick the largest variable. When we'll be coming backwards, then we'll be picking the smallest variable. Let's start. At any point we are beginning our project, for sure we have not consumed any amount of time. The time is at 0. Or rather, if it is our weeks here, we talk about 0 weeks. We work forward. We'll take 0, we add it to 5 for us to come and fill in this particular earliest event time of number 2, which also marks the earliest to which we can finish our activity A. So how do we do this? We'll take 0, we add it to 5, we are using the forward pass. No point of comparison here, I only have 1 arrow, and so I'll be getting 5 weeks, which we can comfortably fill in this particular part of the circle. Again, here we have got no point of comparison. We'll take 0 here and we add it to 4, giving us 4 weeks here. Then we'll work forward on this circle. We require to do a point of comparison, so that we find which is the highest variable. So there are 2 arrows pointing towards node number 4. We'll make the comparison between 5 plus 2, which is 7, and 4 plus 1, which is 5. So 7 is larger, we pick that particular variable. Then for us to work on node number 6, we must have worked on node number 5, sorry. So to find its earliest event time here, it has only 1 arrow, no comparison is required. We'll take 4, we add it to this 5 here, and we are going to have what we can see as a total of 9. Also, to find our earliest event time here, which will also give us the project's duration, we need to go through the 3 routes as we do our comparison. We begin 7 plus 4, that is 11. Then 4 plus 5 here, 4 plus 5, that is coming to 9. And lastly, we have 9 and 3, which is coming to 12. So between 11 and 9 and 12, 12 is larger. We are going to pick that particular variable. Then the latest event time actually takes the earliest event time. So as we work backwards, that figure will still be the same. Okay. Then we are going to now use the backward pass. And as we do this, we'll be picking, if there's any point of comparison, we are going to be picking the smallest variable. When we were working forward, we were using the largest figure. When we'll be working backwards, then we'll be using the smallest variable in our data. So let's begin. I'll start from the last node here. 12 minus, I'm now taking away because I'm moving backwards, okay? 12 minus 3, there's no point of comparison, only 1 arrow coming from node number 5. That will give us 9. Then we can work on this node here because no comparison is needed. 12 minus 4, we have 8. Then here, we're required to do a comparison among these three roots coming from this circle. So I'll begin 8 minus 1, that will give us 7. 12 minus 5, that will give us another 7. And 9 here, 9 minus 5, that will give us 4. 4 is the smallest among those three figures, so we pick that particular value. Then again, we work backwards here. There's no point of comparison needed. Only one arrow coming from this circle. So we have 8 minus 2, that will give us 6. And then lastly, we have 4 minus 4, giving us 0. We make a comparison here. 6 minus 5 is 1. 0 is actually the smallest. We pick that figure, or the smaller figure in this case. Now, if you can't get 0 here, something is not okay with your workings. Make sure you do the forward pass carefully, so that when you're coming backwards, you end up having our earliest and the latest event time for the point which is marking the beginning of your project as being 0, because we have not consumed any amount of time at the beginning of our project. Now, if asked which is our critical path from this project, what are you going to say? There are two ways into which you can do this. Number one, we have already done it in that we have filled in our nodes, the earliest and the latest event times. Any event, whichever I'm calling these small circles or the nodes, any event whose earliest and the latest event times here are the same, the earliest and the latest event times are the same, that particular path actually defines the critical path. Now I can comfortably come and mark my critical path is path B, F, H. The path with the highest amount of time becomes our critical path. But how else can I define my critical path? Assuming I had not filled in my notes, how else would I be able to define the critical paths? Let's come up with all the paths in our project. Let's define all the paths. A path is a route that you follow from the beginning of the project to the end of that particular project. Which routes can we follow? We can have path A through C and then G. We are at the end of the project. How long will it take? Let's count. A has 5, C has 2, that is 7, and we have 4 here. That will give us 11 weeks. 11 weeks. Could there be another path with more than 11? If so, then this path is not critical. So it means you must evaluate all the paths in the project. So I'll go on and evaluate the other path. I can follow path B, D, G. That is another route that we can pass by. The better you do it in a logical manner, like I'm moving from the top of my illustration, going downwards from the top to the bottom so that I don't miss any of my routes or the paths. So this path constitutes how long? 4 for B, then we have 1 for D, and then we have G taking 4. So that gives us a total of 9 weeks. 9 weeks. Another path that we can follow is path BE. We are at the end of the project. You can see this is another route here, BF. We mark the end of the project. How long will it take? 9 weeks. 4 plus 5, sorry, giving us 9 weeks. And lastly, we have path BFH, path BFH, yeah? Let's find out how long it will take us. BFH. And that is going to take us how long? 4 plus 5 plus 3. This will give us 12 weeks. So among the paths that we have already noted from our project network, which among these figures of 11, 9, 9, and 12 is the largest? Of course, it's 12. So we'd actually say the path BFH is a critical path. This becomes our critical path. A critical path is a path to which we believe that it is the shortest route, though given by the longest duration in the project. I believe that that definition somehow contradicts, but that is how we define a critical path. It should be the shortest path followed in the project, but it takes the longest duration to come up with that particular completion of the project. So critical path, among the various paths that you'll have evaluated, pick the one that has the longest duration, and that qualifies to be your critical path. The duration that you get alongside that particular project path, the one we are calling critical, this duration gives us what we call the project's completion time. So we can call this one our project's completion time. So that is how we draw a good network diagram. I repeat, number one, study your project, okay? In that, know all the activities which are defined in the project, and more importantly, interpret the relationship that exists among those particular activities. What are the predecessors in the project? What are the successors in the project? That when we draw this particular arrow, where should it be pointing towards? And where should it be coming from? Think about the predecessors, what happened. Think about the successors, what is about to happen, so that you end up drawing a good network diagram. Always remember to maintain the general rules when you're networking. Only one entry, yeah, only one circle that should be drawn when you're representing a network diagram. Only one exit, again, as you're representing your network diagram. And it is also important, like when you have drawn your project network, that you actually represent what we call a critical path. There are different ways into which you represent your critical path. Like you can see in my case, I've talked about marking all the activities with some double marks on the activities constituting my critical path. One may also think of, assuming this is our critical path, there are some activities and events alongside there. You can also have the double arrows used for that special path to mark that particular critical path. Alternatively, you may actually come in and you thicken the path so that it looks so special. Assuming this is our path here as the one we are calling critical, you may come and you thicken that particular path so that any other path may be separated from the one that you call critical. It doesn't always mean we have only one path we could refine to be critical. There can be even more than one path that you call critical. So what you do, you still mention all the paths which have actually emerged to be critical in your network diagram. Okay, so that is how we can talk about this project and also its complete network diagram. But now, as we are representing our work, would want to know how much will it cost us for this particular project. We'll have a cost of how much. What you do, you go back to the project itself. For each and every activity defining the project, it has a cost associated with it. Sum over the column known as the normal cost. For example, here we have 4, 337. This is 13, 14, 18, 25, 9, that will give us 3,400,000. The figures are in thousands. And so we would actually say our project has the following as we make our conclusion. Number 1, the critical path here is path BFH. That was our critical path. The project's duration is given by 12 weeks. That is our project completion time. And its associated normal cost now you mentioned is, for example, in this case, shillings 3,400,000. And so you make a good conclusion about that particular project. So this was our critical path. Our next session, I'm going to represent now a network diagram like what we have done here. Then we'll have filled in all the details like what we have till to the point we already have the project's completion time, the critical path. But now we come back and we compute what we call the floats. A float is an amount of space-time that an event can actually be delayed in the project. So upon you drawing a good network, you can be able to tell how much of the time you can allow a delay on a particular activity. However, critical activities will always have zero floats. They do not have any amount of time to which one can consider to delay them, because the moment you delay a critical activity, definitely you delay the completion time of the overall project. Therefore, all the activities we call critical, the expectation of the floats, if they were to be computed, they should be turning up to be zeros, yeah? But for the non-critical activities, you may find that space-time as an amount actually defined, because we can allow for a delay for such an activity. So that is our presentation for the network diagram for this particular project and its project completion time, plus the associated cost, as well as the critical path. We stop there for this illustration. More will come as we progress to other areas.